Hi! The video today is going to be on factoring. Alright, so we are going to review old school factoring, and then we have all of these new factoring methods that we are going to learn, and then we're going to review on solving. So, review. All of our old school factoring, we always check for GCF first. No matter what kind of equation we have, we pull out that GCF. And when we pull that GCF out, we divide it out. Difference of two squares, we need two terms, perfect squares. Take the square root of the first piece, which is 3x. Take the square root of the second piece, which is 4. Make one a positive. Make one a negative. Regular factoring, we multiply to the outside and add to the middle. So two numbers that multiply to 6 and add to 7 are 6 and 1. Perfect square factoring is exactly what we just did. Multiply the outside, add to the middle. But when we did that, we get 6 and 6, which means that that's going to be x plus 6 quantities squared. Batman, we got a whole Batman. We're not going to do that right now, but just remember Batman. And that is when your a value is not 1 after you've taken out the GCF, which is 2x plus 3 in this case, and x minus 4. So if you need help with the Batman, make sure that you see me or you go back to our Batman video from our previous unit. Now the new kind of factoring. The first one is sum of cubes. Similar above, we had difference of squares, difference meaning subtraction, squares being perfect squares. Here we have sum of cubes. So sum, we are adding. Cubes, we need perfect cubic numbers so that when I take the cube root of it, it's that number. The pattern is we need to find out what the a and b value is. What number did I cube to get here? What number did I cube to get 64? And then I follow this pattern. So this one's not bad. What number did I cube to get x cubed? Oh, that's x. That's good. That means that my a value is x. If you're not sure about 64, do the cube root in your calculator. So we go to math, number 4. The cube root of 64 is 4. Again, we hit the math button, which is underneath alpha, and then number 4. 4 cubed is 64, so my b value is 4. Now I'm going to take those values, I'm going to plug them into my pattern. So it's a plus b. My a is x, my b is 4. And then my a term squared, my a is x, so this is x squared, minus a times b. A times b minus 4x, and then b squared. My b is 4. 4 squared is 16. And that's all there is to it. So this becomes y equals x plus 4 times x squared minus 4x plus 16. The pattern does look a little intimidating, but it's not. You'll get used to it as you do it more. Now, the next one is difference of cubes. Okay, so this is the same thing, except for difference means that I'm subtracting those perfect cubes. And if you look at your pattern, it's pretty much the exact same equation. The difference comes in with our plus minuses. Everything else is going to be the same. So if I have the sum of cubes, it's plus, minus, plus. If I have the difference of cubes, it's minus, plus, plus. All right, so we have our terms here. So again, what we need to do is we need to figure out what number did I cube to get those pieces. First one's nice and easy. I cubed x. What number do I cube to get 8? That's 2. 2 cubed is 8. So my a is x, my b is 2. So when I fill this in, we get y equals a minus b. So a minus b, x minus 2, a squared means x squared plus a times b. A times b is 2x plus b squared. Our b is 2. 2 squared is 4. Okay, so sum of cubes, difference of cubes. What you want to pay attention to is the plus minuses. And remember, the a and the b is what number did you cube to get that. Our next kind of factoring is actually not new. Grouping. If you remember from Batman, grouping is the second half of Batman. So we group the first two, we group the second two, we pull out the GCF, which is x squared, leaving us with x minus 2. In the second term, remember that needs to be positive, so we pull out a negative 9. Leaves us with x minus 2. And remember, if you do grouping correctly, those pieces are exactly the same. We take the GCFs, those come together to give us our first term. That repeated piece becomes the second term. Now, because we have all of these new kinds of factoring, where you want to be careful not to get caught up is you have to factor all the way. We factored by grouping, but when I factored by grouping using my new method, it left us with something that I could factor using an old method. This is the difference of two squares. I've got to make sure that I factor all the way before I stop. So once you do one method of factoring, keep on going or keep on checking to see if there's something else you can do. All right, the last one is quadratic form. We call it quadratic form because it acts and it uses quadratic factoring methods even though it's not a quadratic. So if I had this is regular factoring. We multiply to the outside and add to the middle. So two numbers that multiply to 8 and add to 6, well, that's 4 and 2. Now if I look at the slight change, it's still coefficients of 1, 6, and 8, but now it's x to the 4th, x squared, and 8. So it's going to be treated the same way, multiply the outside, add to the middle. The difference is the x to the 4th and the x is going to make this an x squared plus 4 and an x squared plus 2. So it follows those quadratic rules, but we've got to change it from an x to an x squared. All right, so those are all of our new factoring methods. Now we're going to do some solving. So as you get ready to solve, we're going to think about that fundamental theorem of algebra. Think about how many solutions you should expect to find in the end. That kind of helps check your work a little bit. So when I look here, the first thing I always do is I pull out that GCF. In this case, it's a 2x, and that leaves me with x cubed minus 64. After I pulled out that GCF, it left me with the difference of cubes. Remember, the a is what did you cube to get x cubed? The b is what did you cube to get 64? So we have our GCF. With the difference, it's minus plus plus. Or look at the pattern that you have on the other page. So this becomes your a minus your b, your a squared, the a times the b, and then your b squared. So we check to see, can I factor? No, GCFs can't be factored. My first term, x minus 4, that's factorable all the way. When you look at the trinomial, one thing that you may want to remember so that you don't waste all of your time is the trinomial from the sum and difference of cubes will never be factorable. So don't try Batman, don't try all these crazy things. If you had just used sum of cubes or difference of cubes, the trinomial is never, ever, ever, ever factorable. Okay, so this is factored form. We've factored as far as we can go. I set each piece equal to 0. 2x equals 0, x equals 0, first solution. And I know I'm going to find 4. This means x is equal to 4. Now I have my trinomial. The easiest way to solve a quadratic is factoring, but we just said we can't factor. So this is what we spent an entire unit on, is all the different ways that you can solve a quadratic. You can solve by factoring. Oh, doesn't work. Square roots, doesn't work because we have an x term. Graphing, it may work, it may not. We don't know. It only shows real. So it comes down to the quadratic formula or completing the square. I always choose quadratic formula, but it is completely up to you on what you feel comfortable with. So opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a. I simplify the discriminant underneath that radical and I get a negative 48. Now we need to break this down. So I can see right now that if I had used the graphing, it would not have worked. When I break down 48, I get 16 and 3. There's my perfect square. So negative 4 plus or minus 4i root 3 all over 2. We break that down and we get those last two remaining solutions. Negative 2 plus or minus 2i. Oh, I don't know why I'm writing this up. Negative 2 plus or minus 2i root 3. So there are our four solutions. We have 2 real and 2 imaginary. Okay, next one, solving. We check for our GCF first, and we actually do. We have an x that we can pull out, leaving us with x cubed plus 3x squared minus 4x minus 12. When you have 4 terms, the only option you have is grouping. Group the first 2, group the second 2. Pull out that x squared, leaving you with x plus 3. Pull out the negative 4, leaving you with an x plus 3. And we have that whole GCF out there. So now we have 0 equals the original GCF. I take those 2 GCFs that we pulled out from grouping. Those go together. The repeated piece is our next one. Now, once again, after I did grouping, it created another thing that I could factor. That's the difference of 2 squares. Again, we want to make sure that we factor as far as we possibly can. I know I'm going to find 4 solutions. Here we have x is 0. Here we have x is a negative 2. X is a positive 2. And x is a negative 3. In this case, I have 4 real solutions. Our last one. Now this is the difference of 2 squares. It's one of our quadratic factoring methods, but it's going to follow quadratic form, even though it's not an x squared. Remember, difference of 2 squares, we set it up. We take the square root of the first term. The square root of 81x to the 4th is 9x squared. We take the square root of the second term, which is 4. 1 positive, 1 negative. We look at our pieces. This is not factorable. This one is. We have the difference of 2 squares again. So this becomes 9x, not to the 4th, 9x squared plus 4 because that wasn't factorable. When I do the difference of 2 squares again, that's 3x plus 2 and 3x minus 2 because the square root of 9x squared is 3x, the square root of 4 is 2. Now that's factored all the way. Now I need to solve this. We have 9x squared plus 4 equals 0. For this solving quadratic, I'm going to use solving by square roots. I move the 4 over. I divide by 9. We get x squared equals a negative 4 over 9. We square root. Now here, the negative makes an I on the outside. We're lucky. We don't have to rationalize. These are perfect squares. The square root of 4 is 2. The square root of 9 is 3. So this gives us 2/3 I. Oops, plus or minus. X equals plus or minus 2/3 I. We set 3x plus 2 equal to 0. We move the 2 over. 3x equals a negative 2. X equals a positive 2/3. And that means that that's x equals, that's a negative 2/3. That means that this is a positive 2/3. So once again, we expected to find 4 solutions. We found 2 imaginary here and then 2 real there. Okay, so all old school factoring is going to continue to come into play, and now you have 4 new factoring methods to go along with those old factoring methods.